Hello, in this video we are going to solve question number 1 of GATE 2018 physics paper. Question related to mathematical physics. The question is the eigenvalues of a Hermitian matrix are all real, imaginary, modulus 1 or real and positive. First of all, the question is what is a Hermitian matrix? So let us assume that we have a matrix A. And A is said to be Hermitian if its transpose complex conjugate, which is represented by this A transpose and then O bar, is equal to the original matrix A. If this equation is satisfied, then the matrix is said to be Hermitian. For example, if suppose you have a matrix A, which is 3, 2 minus iota, 2 plus iota, and 4, then you just take the transpose of it, just swap the rows and columns. It will be 3, 2 plus I, 2 minus I, 4. And now you just take the complex conjugate of this. So real part will remain as it is and the complex part will become 2 minus iota. It will become 2 plus iota and 4. Now this is equal to the original matrix A. Therefore, the matrix A is Hermitian. Okay, and the eigenvalues of these Hermitian matrix are always real. This is one of the property because we will also prove this mathematically, but remember that eigenvalues of Hermitian matrix are always real, as these eigenvalues always represent some physical quantity, and this physical quantity can't be imaginary. So that's one way of remembering that eigenvalues of real Hermitian matrix are always real. Now let us prove this. So let us assume that if a matrix A and its Hermitian is represented by A theta, and let us assume that A is Hermitian, that is as represented in this equation, that A is Hermitian. Therefore, A is just equal to A theta. Now we have the equation that A of x is equal to lambda times x. Now this is the eigenvalue equation. So we just take the Hermitian of both the sides. So this will be, just open it, it will become x theta, A theta. Lambda is some scalar eigenvalue, so it will just be x theta. Now since A is Hermitian, therefore A theta will be just A, and lambda is just, it will be just complex conjugate, like it's just a scalar, and x theta. Now multiply both sides on the RHS, multiply both sides by x. So you operate this on x, or in other words you can say, so it will become, if we just operate this on x, so we'll get something like this. Now we know that this is the equation which I'm writing it again on here. Now we know that Ax is nothing but lambda times x from the eigenvalue equation. So we can take it out and we can write like this, it's just a scalar, so lambda bar x theta x. Further we simplify it, we'll get lambda minus lambda bar is x theta x is equal to 0. Now by definition, this Hermitian matrix or this cannot be 0. So this is by definition, because so what is we are left with is that lambda minus lambda bar is equal to 0, or which means that lambda is equal to lambda bar. So this equation signifies that eigenvalue lambda is always real, because if it was complex, then its complex conjugate could not be equal to lambda. For example, if lambda was some imaginary iota, then lambda bar is minus iota, and we know that these two are not equal. Hence it proves that eigenvalue lambda is always real. So the correct option is A. The eigenvalues of Hermitian matrix are always real. Thank you for watching this video.